Okay, number 6. Written response number 6. Find the points in the parabola that are closest to the point 0, negative 1. Okay, so just to give ourselves a bit of an idea of what this looks like, x squared minus 3 is going to look like this, sort of. Okay, it's a terrible parabola, but you get the idea. Where this is right here is going to be minus 3, and I'm looking for the points on the parabola that are closest to that point right there, 0, comma, negative 1. I could use the distance formula, but I really think this is a better method because it's quicker here. So what I'm going to do here is I'm going to set up the line connecting the point 0, 1 to the parabola, and the coordinates of the point on the line here, x comma y, okay, on the parabola here, except that I can do better than that. I can say x comma x squared minus 3. Okay, so these are all the points on the parabola. Now, the point here, when this point right here is closest to this point, okay, the line connecting them that directly, those 2 points directly, was going to be perpendicular to the tangent line. Okay, so what I got to do here is set up some slopes here, and then because I know the way slopes work, I can adjust for the fact that they're supposed to be perpendicular. So first of all, the slope of that line, okay, the slope of the line connecting those two here is going to end up being x squared minus 3 minus negative 1 all over x minus 0. Okay, so that's plugging in that point and this point right here into the slope formula. That's the slope of that line right there. And I will simplify that. That's going to be x squared, negative 3 minus negative 1 is going to end up being negative 2 over x. Okay, so that's the slope of that line. The slope of our tangent line is going to be equivalent to the derivative of the function, which in this case will be 2x. Okay, now these two slopes are not the same, okay, because one goes like this, the other one goes like this. But to make them the same, I simply take the negative reciprocal of one of them, and I'll probably do it with this one right here. So that means x squared minus 2 over x should equal the negative reciprocal of the slope of the tangent. And now these two should be equivalent. And so what I'll do here is I will do my little, I know it's not called this, but cross multiplication. So this will end up, or actually, you know what? No, I better do it like this. So I will multiply that through and I will get 2x cubed. I'm actually going to leave the negative there. I'll put the negative on that x when I bring it up here. So this will be 2x cubed minus 4x. Bring that x over, so it'll be 2x cubed minus 3x equals 0. Okay, now I'll take out the common x, and I'm left with 2x squared minus 3 equals 0. And I'm left with x equals 0, and the positive and negative square root of 3 halves. Okay, those are the values where this goes to 0. Now, I want to know where it's closest. So what I got to do here is just quickly investigate the intervals of increasing and decreasing. Now, I also have a sense of what this is going to do. Like, I already know that this is going to be a local maximum, and these are my local minimums here. But we're going to look at it like this anyway. So this will be negative root 3 halves, positive root 3 halves. I'm just going to look at these factors here. If I choose a number less than this, let's say negative 10. Okay, this is negative. If I put negative 10 into this right here, because remember it's the derivative, this thing right here that I want to check to see where it's maximum or minimum. If I plug that in here, this will be negative, this will be positive. So over here, this is going to be negative. If I choose a number in between there, this is still going to be negative, but this part right here will also be negative because the x squared is going to be quite small. When I subtract the 3 from it, those won't balance out. Those will balance out here, so it's supposed to be positive. On the flip side, though, then this term becomes positive, and so this one stays negative, so negative, and then out here, again, positive. So I'm decreasing and increasing, so there's my min, okay? Increasing and decreasing, so there's a local max, decreasing and then increasing, so there right there is another local min. Okay, and if I plug those in to the original equation here, this x squared minus 3, if I plug this in, just think about it, this ends up becoming 3 halves minus 3, so it becomes negative 3 halves. So the two minimums here become plus or minus root square root of 3 over 2, comma, negative 3 over 2 as my y coordinate.